Good morning, everybody. Happy Thursday. So we're over the hurdle of the situational problems. So I hope it went well for everybody and that there were no unexpected surprises there. If you have any questions or concerns, feel free to send me an email or anything or ask during the class. No problem whatsoever. Before you ask, I do not have them corrected. You did write them yesterday. So don't stress about it, okay? So it'll be corrected soon. But the focus now is to be moving forward for the final, which is on Tuesday. So that brings me to this point here. I posted some things yesterday. You might have taken the afternoon off because you just did an exam, but regardless, I posted some things yesterday. First thing was the important notice that I gave you yesterday in class. Well, like during when the exam was over. The thing that I really want to highlight, first of all, we've looked at this together already. Your exam, here, just let me screen share to make sure everyone can see what I am seeing. Share, here we go. So yesterday, like I said, I posted some things. So under important notice, this was the document that I gave you yesterday. So there are a couple of things that I want to highlight on this document. First of all, the schedule for the exams is on the back. Our class is on Tuesday, July 25th at 9 to 12. So please show up early, make sure that you're here on time. You'll be able to find your room and get settled. The important thing too, the other thing to highlight about this, students will not be permitted to write their exam if they are more than 30 minutes late. All exams are being held at Lindsay Place, just like your exam was yesterday. What do I need to bring to my exam? All students should bring a student ID card, okay? So you need to have an ID card so that we know that you are who you are writing this exam. So it doesn't matter, it could be school ID, it could be a Medicare card, it could be a driver's license, if you're really desperate, a passport, but any little piece of ID that has your picture on it, just to make sure, like I said again, that you are who you say you are. We trust you, but we have to be thorough. So you have to have an ID card with you, and then everything that you need for your exam as per usual, the pen, paper, not paper, pencil, calculator, water bottle, little snack if you want. You will be able to access your marks on August 3rd the same way you access your MELS marks after you wrote your exam. So you have this information, and when you go to that site and plug in your information, you'll be able to see your marks as of August 3rd. So August 3rd is a Thursday. So the Thursday after, that's when you'll be able to access your marks. The question is, I don't have my school ID from this year, so can I bring one from last year? It needs to be a picture ID, okay? They're not gonna be like, oh, you're not, like, the thing for us is that your name that is on the exam matches your name and your picture. So we're just making sure that you are who you say you are, kind of thing, right? So it doesn't matter what kind of ID it is. Some of you may not have the picture ID Medicare card yet, but that would work too if you have it. So anything that's picture ID is fine, even if it's from last year. So all of this information has to do with your marks, which will be accessible to you as of August 3rd. And like I said, the most important part of this is try to be on time, bring your ID, and bring all of your materials. You've written finals before, we kind of know what this story is. I will be there the day of your exam. I am going to be in one of the two classes. So I will either be in your class or I will be in the other group's class. I don't know yet. They haven't scheduled it and told me which class I'm going to be in. However, they're going to put you guys and the other class side by side or across the hall from each other. That way, if you have questions, I can go in. I'll just swap with the teacher that you have to be able to answer your questions. So I will be there. I may not be with you the whole time, but I will be able to pop in a couple of times during the exam to answer any questions. If you don't see me, if I'm not in your room, chances are I won't pop in the first 15 minutes just to give you some time to read over the exam and really look at it and do some problems. So don't panic, but I will be popping in if I'm not in your room. The question is, we're not going to know the marks from the SIP prob alone. I haven't decided yet, but 100% I will not be giving you those marks before Tuesday. So you will not get those marks before your other final. Are there any more questions about the final or about the SIP prob? Okay, cool. So before we get started, just a couple of explanations. So today, what we are going to be doing is we have one specific thing to cover in probability and one specific thing to cover in statistics, 1/2. And then that's the end of the new material. I'm hoping to get through it all today. Worst case scenario is we'll have like that little part of statistics left to cover tomorrow. The rest of tomorrow will be a review period. So basically what I'm going to be doing is, if you look, the other important announcement that I posted yesterday was that under the About section, I posted a new folder, just a bit different. Oh, okay, here we go. This new folder, Review Finals and Solutions. Okay, so there were a couple of like practice finals with solutions that I posted. So you can go through them as good practice. And the other thing that is really important, like I've said before, are the assignments. So again, I'm noticing a trend in this class specifically that a lot of people aren't completing the assignments. Those are final exam level questions. So those are types of questions that you can expect to handle for the final on the new material. So make sure you're going over that. If you need the list, remember that the list is here as well in the notes. You have the course outline. So you have the course outline, which means you have access to all the topics that you are responsible for, including the topics that you're responsible for from the CST. So a lot of the stuff we didn't look at together. Trig and triangles, we haven't looked at together, and systems. So what I can do is I could post some review notes in this folder, in the notes folder, and maybe some review problems with solutions for the CST stuff. But just know that you are responsible for that material, and it does come up a lot in the finals. So make sure that when you're doing your review and when you're doing your memory aid, that you do include all of this kind of stuff here. So I will be doing that this afternoon at some point. I've already done some review notes for triangles and trig. So you have some triangle stuff here with the congruence and similarity with some examples to go over, and trig as well. The only thing is that the trig stuff, this is all stuff you learned last year. Actually, I'm going to update these notes because you don't need cosine law and you don't even need sine law. You just need the area and you need SOHCAHTOA. So I'm going to update these notes, but regardless, you have some triangles and trig stuff. I already gave you the line stuff, all of the different line stuff you already have, the functions you already have, all the analytic geometry you already have that I posted with the other notes. So when we did like distance point to line and all that stuff, I give you all of the analytic geometry so you could look over that stuff. So the only thing you're really missing at this point is systems, and I'll just update the trig one, and then I'll post some review problems that you can go over with some solutions just to help you get prepared for the final. Other than that, you should be really, to get prepared, you should be doing those review finals. Some of those questions are extremely difficult. So if you're getting those problems or if you're having a bit of difficulty, please do not fear. They are a higher difficulty level. But the assignments and the quizzes and the handouts are extremely good practice for you. And like I said, feel free to send me emails for clarifications at any point. So before we get started, are there any questions on any of the assignments or handouts that you've covered so far? I gave you assignment 10 feedback yesterday for those of you who completed it. We're few and far between, but regardless. So that solution, those solutions have been posted as well, but is there anything that you want to go over before we get started? So while I'm waiting, I'll just open the lecture here. So I'll wait another minute, but as of now, there's no questions or anything. Take a look at assignment 11 today, if possible. That stuff we did cover on Tuesday, so you're able to do all the questions for that. So that's something definitely to look at. Anything else? Okay. So on Tuesday before the SIP prob, just to get our brains back in gear, because I know on Tuesday our brains were pretty much in SIP prob gear, we continued with probability. And we did some tree diagram stuff. And then we started talking about mathematical expectation. So we talked about a random variable. So a random variable is each outcome of a random experiment. We can then group these random variables, assign values and probability to them. So this happens a lot when games are being played. So arcade games, fair games, like as in traveling fairs, casino games, stuff like that. So basically you go to a game and it costs a certain amount of money to play the game. And depending on what the outcome is of the game, you can either lose money or gain money or whatever. And the expected value is basically the average of what you can expect to get based on the probabilities of the outcomes and based on what you would have to pay or what you would get. So representatively, what this means is you have 3 different cases. So if the expectation is 0, that means on average you would expect to break even, which means that the game is fair. So if you're expecting to break even, that's fair. If the expectation is positive, what that means is on average you would expect to come out ahead, meaning that you would expect to receive positive money. Now, this is not the money that you will get, it is the probability, it's the expected value on average. If you played this game a certain amount of times, what would you expect to do? What would you expect to gain or lose? So if your expectation is positive, that means that the game is favorable to the player. So this is a game I want to be playing because I would expect to earn money. If the expectation is negative, what this means is on average, I would expect to be losing money if I played this game. So this is not a game I want to be playing. So there are 3 different types of problems that we can do. So just like with mean deviation, you create a table and you're going to fill out the table, and that's how you're going to be calculating your expected value. So you have outcome, probability, net gain, and the product, which is the product of these 2 columns. And the expected value is we take this column and we add it up. The net gain, so basically what I expect to gain is how much I would get minus what I've paid. So if I pay $5 to play a game and I would win 20, my gain would be $15 because I earned 20, but I paid out 5. So I'm up by 15. So that is your net gain. So we're going to be accounting for that in this column right here. So there are 3 different types of problems that you can expect with this, and often they come up as a Part C question. So either you're going to determine that a game is fair, or you're going to be determining a missing value given that the game is fair. So if you know it's fair, the expected value is 0, and you're going to solve for some missing value based on that. Or you could have a combination of these 2 things. So oftentimes in Part C questions, what they like to do is they'll give you 2 different games, and one of them you'll be working for a missing value based on the fact that it's fair, and the other game you'll be working forwards to find what the expected value is. So you'll be doing 2 separate tables for the same problem. So the last thing that we did was we did a problem. So here there are 20 marbles of the same size in a bag, 3 red, 7 white, and 10 blue. The bet is $10. You are to draw 1 marble from the bag. So if you pull out a red, you win $30. White, you win 15, and blue, you don't win anything. You lose your bet. So we filled out our table. We had outcome, our red, blue, and white. You then need the probability of each of these outcomes. So there are 3 red marbles out of a total of 20. So the probability is 3 out of 20. Blue, there were 10 out of the 20, so 10 over 20. And white was 7 over 20 because there's 7 out of the total of 20. And like I said, normally we want to reduce probabilities, but for the probability and for the product, we don't. We want to keep them all on the same denominator because then it makes our solving easier afterwards. And I'll show you an example of why after. Then you fill out your net gain. So your net gain, remember, is what you win minus what you bet. So if I get a red, I won $30, but I paid 10, which means that if I pull a red, I gain 20. Blue, I just lose my bet. So I paid $10, but I didn't gain anything back. So I'm negative $10. And if I pull a white, I win 15, meaning that I paid 10 and I won 15. So I'm actually up by 5. For the product column, you take this probability column times the net gain. So again, we had 60 over 20, negative 100 over 20, and 35 over 20. And we kept them, even though all of these could be reduced, we didn't reduce them. The expected value was, we add up this column, we got negative 5 over 20. It's not fair because it's not 0, and because it's negative, this is not a game I want to be playing because on average I would expect to lose money. I would expect to lose this much money. So it's not favorable to the player. Okay, so now that our brains are back in gear, we'll do a couple of more examples because like I said, you definitely can expect to have this as a 10-pointer. So you don't want to be shocked when that happens. So a casino features a game of chance called the maze. The contestant must drop a marble into the maze below. The outcome of the game depends on the compartment in which the marble lands. So if you ever watch The Price is Right, this is kind of like Plinko, where they have this little chip and they drop it down, and they, depending on what slot it ends up in, they could win different money, like different values of money. So here, each contestant must bet $5. The game is fair. So when they tell you the game is fair, that means the expected value is 0, and that means we're missing some sort of other value, okay? So we have this little maze. So we have 3 different outcomes that we could have. I could land in compartment A, I could land in compartment B, or I could land in compartment C. Now the tricky part of this is figuring out the probability for each of these things. So I drop my marble in. Either it's going to go here or it's going to go here. So picture this as kind of a sideways tree diagram. So either I could go here or I could go here. The probability is 1/2 because there are two different tunnels that the marble could choose. So let's follow here. If the marble chooses this path, again, it splits here 1/2 or 1/2. So if I follow this branch, it's 1/2 and 1/2, meaning that this branch would be 1/4. If I follow this branch here, so in the blue, in the B, I have this one and this one, so I have 1/4 in here. So let's follow the right branch. So if I go in this branch, then I have another two-way split. So the probability of me going on this side is 1/2, or the probability of me going on this side is 1/2. So if I follow this branch here and I go this way, I have again the 1/2 and the 1/2. So I have another 1/4 in compartment B. And then if I'm here, I have another 1/2, 1/2 split. So if I go, if I go this way, I have 1/2, 1/2, 1/2. So if I do 1/2 times 1/2 times 1/2, that gives me 1/8 in B. And if I follow this route, I have the 1/2, then the 1/2, then the 1/2 to give me the 1/8 in C. So these add up. So 1/4 plus 1/4 plus 1/8. That gives me 5/8. And since these are over 8, I actually want to write this as an over 8 as well. So the probability of landing in A is 2/8. The probability of landing in B is 5/8. And the probability of landing in C is 1/8. Is everyone clear on how I got these numbers? Okay, so now we need to figure out the net gain. So if we remember, the net gain is what we win minus our bet. So in compartment A, we lose the money we bet. So if I have to pay $5 to play this game, which is what it told me, I have to bet 5. And I'm just going to lose the money that I bet. I'm negative $5 here. And the product then is 2/8 times negative 5, which gives me negative 10/8. In B, I keep the money I bet. So I don't pay anything out and I don't win anything. This gives me 0 and I can gain of 0. 5/8 times 0. So from this outcome, we get a 0 here. In compartment C, you keep the money you bet and win a certain amount of money. So I'm going to keep my bet and I'm going to win something. I don't know what that something is. So when I don't know what something is, I call it X. If I didn't keep the money I bet, it would be X minus 5. But since I'm keeping the money I bet, whatever I win is actually my gain. So then my product is 1/8 times X, which just gives me X/8. When you are told the game is fair, that means that the expected value is 0. And we know that the expected value is the sum of this column. So 0 is going to be equal to negative 10/8 plus 0 plus X/8. And since I have this equation, I can solve for my value of X. Now the reason we keep the denominators the same is if the denominators are the same, I can just multiply by the denominator and the denominators go away. So I get 0 equals, this will cancel with this, and this will cancel with this, and all of a sudden my equation becomes very simple to solve, and I don't have to deal with denominators. But if you do not keep the denominators the same, if you start reducing and simplifying and changing them, you can't do this trick, which is fine. That just means you're adding, subtracting, multiplying, and dividing fractions. I know most of you prefer not to do that, but if you find it easier than doing this step, that's fine. So if I move the 10 over, 10 is x, which means that the money that I win, if I land in compartment C, will be $10. If it's $10, this game will be fair. If it's not $10, this game, depending on what its value is, the game will either favor the player or the game will favor the house. So it's the casino or the circus or the arcade or whatever it is. Are there any questions about this problem? So like I said, these are the two different case scenarios. Very simple case scenarios, but examples of the two case scenarios where one, you have to calculate the expected value, and one, you're told the expected value is 0. So you have to calculate some sort of missing number based on the fact that the game is fair. This isn't an estimation. If the game is fair, X is 10, period. We know the game is fair, so in order for the game to be fair, it has to be 10. If you're not told the game is fair, there's nothing you can do here. So those are the two different case scenarios for problems. Either you're calculating the expected value, or you're calculating a missing value based on the fact that the game is fair. I don't subtract my bet from 10 because in this compartment, it says you keep the money you bet. So I'm not losing that 10. If it didn't say that, if it just says you win a certain amount of money, you would subtract your bet from the 10 or from the X in this case. It would have been like a minus 10 here. And then you would have just had a minus 5. You just would have had like a minus 5 here that would have factored into your equation. But because it says I'm keeping that money, then I don't lose 5. I'm actually keeping the 5. And whatever I win, I keep as well. Let's take a look at a couple more examples. So this is a type of final exam level question where you actually have to use, you have to do an entry table and expected value. So a fair die has 20 faces, 14 white faces, and 6 black faces. There is a star on 12 of these faces and a heart on the other 8 faces. If you roll this die, given that a star is rolled, the probability of obtaining a white face is 2 over 3. So you saw the word given in probability, which means you're going to be doing something with conditional probability. So this, again, is a final exam level question because you're doing the expected value, but also working with conditional probability. So a game of chance is described. After placing a bet, the player rolls the die. If a black face is rolled, the player will not receive any money. If a white face with a star is rolled, the player will receive $20. If a white face with a heart is rolled, the player will receive $10. The game is fair. How much money must the player bet before rolling the die? So before I can start filling out my table, I know that I'm going to have 3 different outcomes, okay? So I know that my outcomes are black face, then I have white face with a star, and I have white face with a heart. Those are the 3 different case scenarios. But I don't know the probability right now because I don't know the number of each. So what I'm going to do is I'm going to create a double entry table. So I have white and black. I have star and heart. And I have total and total. I know that there are 20 faces. What other information do I know? I know that there are 14 white and 6 black. So 14 white and 6 black. What else do I know? I know that there are 12 hearts and, no, 12 stars and 8 hearts. 12 stars and 8 hearts. So the probability of white, given that it's a star. So we're going to do the probability of white, given that it's a star. So I know that that probability is the number in their intersection. So it's the number of white and star, not an A, white and star, divided by the total number of stars. So now I'm going to fill out what I know. The probability of white given star, they told me is 2/3. The number of white and star is here. I don't know it, so I'm going to call it X. But I know that the number of stars is 12. All of a sudden, I have a simple calculation that I can do, so I can cross multiply. So 2 times 12 is 24 equals 3x. And I divide by 3 to give me 8. Is everyone clear on how I did this? Okay. Take that as a yes. So 8 goes in here. From this, we can figure everything else out. So 12 minus 8 gives me 4. 6 minus 4 gives me 2. 8 minus 2 gives me 6. So now I can fill out probabilities here. So this one I could have already filled out, but regardless, how many black faces are there? There are 6 out of 20. How many white stars are there? So white star is 8 out of 20. And a white heart is 6 out of 20. Remembering that these 3 columns should add up to 1 because you have the probability of the whole situation. Now, I don't know the bet. So I'm going to call the bet X. So I'm going to look for each case scenario. If a black face is rolled, the player will not receive any money. So what is their net gain? Well, their net gain is they don't receive any money and they bet X dollars to play this game. So if I multiply, I get 6/20 times negative X. That gives me negative 6x/20. If I roll a white face and a star, I get $20, but I have to subtract my bet because it doesn't say that I keep my bet. So my product now is going to be 8/20 times 20 minus X. And that gives me 8/20 minus X/20. And we keep these denominators so we can do that trick and make it easier to solve. White face with heart, we get $10. So 10 minus x is going to be my net gain. So I have 6 over 20 times 10 minus x. That gives me 6, 10 minus x over 20. We are told that the game is fair. So fair, fair means my expected value is 0. So meaning when I sum up that last column, I should get 0. So negative 6x over 20 plus 8, 20 minus x over 20 plus 6, 10 minus x over 20 is going to give me 0. Everyone clear with that? Okay. Now, because they all have the same denominator, I can do the trick where I just multiply by the denominator and they all go away. So this 20 cancels out with this one to leave me with negative 6x. This 20 cancels out with this one to give me 8, 20 minus x. And this 20 cancels with this one to give me 6, 10 minus x equals 0. And all of a sudden, my equation looks a lot more straightforward to solve. So I'm going to distribute this 8 inside. And I'm going to distribute this 6 inside. It's not equal to 20 because 0 times 20 is 0. That's why this trick is really handy. So now I put my x's together. So I have negative 6, negative 8, and 6. So that gives me negative 20x. And then the 160 and the 60 go together to give me 220. If I move this over, I get 220 equals 20x. And divide by 20 to give me 11. So in order for this game to be fair, I have to have an $11 bet associated with this game. If the bet isn't $11, either the game will favor the player or it'll favor the house, but it will not be a fair game. So not necessarily one that we want to be playing. So again, this is a case scenario where you're told that the game is fair and you're missing a piece of information in the game. So when you're missing a piece of information in the game, it goes into the table as x. You're still creating this equation. You're keeping the denominators the same. That way you can cancel them out easily. And then you're solving a simple equation. So far, so good? Scroll up, please. Sure. Is here good? Okay. I'm going to give you 2 minutes. I want you to try to set this problem up by yourself, and then we'll take a look at it together. Do we need another minute, or are we ready to get started? Sure. One more minute. Net gain is what you win minus what you had to pay to play. This one's very tricky. So let's take a look at it. A bag contains 10 $5 bills, 4 $10 bills, 150, and a number of $20 bills. If you bet $15, then you draw a bill from the bag and keep it. The expected gain is 0. So either I could draw a $5 bill. I'm going to zoom in here. Either I could draw a $5 bill, a $10 bill, a $20 bill, or a $50 bill. This is where it gets tricky because the probability is what we don't have. So I have 10 $5 bills. I have 4 $10 bills. I have 150, and I don't know how many 20s I have. So my total is X plus 15. So what happens with the probability is that it's each of these over the total. So the probability of me getting a 5 is 10 over X plus 15. And the probability of me getting a 10 would be 4 over X plus 15. And then the probability of me getting a 20 would be X over X plus 15. And the probability of me getting a 50 would be 1 over X plus 15. Is everyone understanding that part of it? So that was the tricky part. Okay, so the net gain. If I'm betting, my bet is 15. My net gain here is I would win 5, but I bet 15. So overall, I'm down $10. So my product is 10 over X plus 15 times negative 10, which gives me negative 100 over X plus 15. If I pull out a 10, but I bet 15, overall, I'm losing 5. So here I get 4 over X plus 15 times negative 5, which gives me negative 20 over X plus 15. Here, if I pull out a 20 and I bet 15, I'm gaining $5. So I have x over x plus 15 equals, times 5. Gives me 5x over x plus 15. And finally, if I get a 50 and I paid 15, I'm getting $35. So 1 over x plus 15 times 35 gives me 35 over x plus 15. Is everyone clear on how this table got filled out? Okay. So now we know that the game is fair. So the expected value is 0, which means that I take the sum of the last column, negative 100 over x plus 15, minus 20 over x plus 15, plus 5x over x plus 15, plus 35 over x plus 15 equals 0. Now, this is the good part of this. It doesn't matter what the denominator is, the denominator trick works. So all I have to do is say I'm multiplying the entire equation by whatever the denominator is, as long as the denominator is the same, and they all disappear. So x plus 15 disappears here. X, when I distribute this in, remember it distributes to each term, this will cancel out here. This cancels out here. This cancels out here. So all of a sudden, I'm solving a very simple equation from what looked like it was going to be a very complicated one. So I put my numbers together, and I get negative 85 plus 5x. If I move the 85 over, I get 5x equals 85, and I divide by 5 to give me 17. Now, remembering what this means, there are 17 $20 bills in my bag. If this game is fair. If I have 18 $20 bills, the game won't be fair. If I have 10 $20 bills, the game won't be fair. Is everyone clear on what just happened? No, not the full screen. I wanted to zoom out. Hello. Okay. Why do you hate me? Okay. Now, just before we continue, the thing you have to remember about this is a real life situation in a sense. So if I solve that problem and I got x was 15.7, I can't have 15.7 $20 bills. A $20 bill, either I have one or I don't. So if I got a decimal number for my x value there, I've made a mistake. So with certain types of problems like this one, you have to analyze your situation. So if you get a bet that's like $2.50, that's fine because I can pay $2.50 to play a game. But I can't have 2.5 marbles in the game, or I can't have 2.5 cards in the game, or 2.5 bills in the game. Doesn't make any sense. How are we feeling about this? Do we need to see one more problem, or are we feeling pretty confident? One more. Okay, one more it is. Yes. All righty. So what we are going to do is we're going to do one from the handout. So you have the handout here. If you go back to your stream, things are going a little funky today. If you go back to your stream here, what is happening? Okay. Then just scroll down a little bit and you have class 12 handout. So we're going to do a problem from there. Just so you know, class 12 assignment that was posted, the Google Docs, there's only a Google Docs this time. Okay, there's not a Google form because you usually get this as a part A question, part C question, excuse me. So there are 3 practice problems with mathematical expectation. So one of them you have to calculate if it's fair or if it's not fair. In this one you have to figure out what the bet is. And in this one you have 2 different games. One you're working backwards to find the bet and the other one you're working forwards to see if it's fair. So those are pretty much the 3 different types of questions that you could get on the final. So in the meantime, what I'm going to do is I'm going to take a problem from the handout. So we go to the handout, class 12. I don't know why it photocopied like that. Anyways. So take a quick minute, look through the problems. If there's anyone you'd like to see in particular, we can do it. I don't mind. Except number 4. Number 4 is really long. How much must they bet? Is this game fair? Let's do number 1. Number 2, sorry. Let's do number 2. So we have a game that involves spinning a pointer attached to the center of a wheel divided into 8 congruent sectors. So you're either spinning a green, a blue, or a red. Contestants must bet a certain amount of money to play this game. If it stops on a blue sector, the contestants will win $20 and keep the money they bet. If a pointer stops on a red sector, then contestants will win $4 and keep the money they bet. And if the pointer stops on a green sector, then contestants will lose the money they bet. The game of chance is fair. How much money must contestants bet to play this game? So, let's try this out. We have different case scenarios. So we have blue, red, or green. The probability, we have 8 different sectors. 1 is blue, so 1 out of 8 is the probability of me getting blue. 3 out of 8 are red, so the probability here is 3 out of 8, which leaves me with 4 green. So there are my probabilities. The net gain. If a pointer stops on a blue sector, then contestants will win $20. So they win 20 and keep the money they bet. So in reality, I'm up $20. So my product becomes 1 over 8 times 20, which is 20 over 8. If the pointer stops on a red sector, the contestants will win $4 and keep the money that they bet. So I'm keeping my bet, which means I'm actually up $4. So I have 3 over 8 times 4, which gives me 12 over 8. If the pointer stops on a green sector, then contestants will lose the money they bet. So if I stop on a green, I lose the money I bet. So whatever I bet, I'm losing that money. So if I have my product, I have 4 over 8 times negative x. That gives me negative 4x over 8. I am told that the game is fair. So that means that the expected value is 0. Which means that 20 over 8 plus 12 over 8 minus 4x over 8 gives me 0. We can use the trick of multiplying this whole thing by 8 to get rid of the denominators. So this leaves me with just 20. This leaves me with just 12. And this is negative 4x. These numbers go together. 32 minus 4x equals 0. The negative 4x moves to the other side. And I can divide by 4 to give me x is 8. What this means is for this game to be fair, I have to the bet has to be $8. How do we feel? Always, always, always do the table. Okay? It just makes your life really simple. It's more organized, it's more straightforward, and just by making the table, you'll get points. Just by writing this sentence, you can get points because you're acknowledging that you understand that a fair game means expected value is 0. So even if you're having difficulty creating this part of it, just doing the table and writing this sentence will give you points. And on a 10-point question, you want as many points as you can get. Are there any other questions? Okay, so like I said, you can probably expect that on as a 10-pointer. Happens a lot. Save. So remember now that you can go and complete this assignment with the 3 different mathematical expectation questions. I will be checking this one on Saturday. I want to give you your feedback for assignment 12 and assignment 14 on Saturday. That way you still have Sunday, Monday to prep and you're not expecting feedback on assignments. Okay, so we are now going to go into class 14 notes, which were posted. So class 14 notes are all about statistics. What we're going to be doing is we're just going to do a very, very quick review of mean deviation. Actually, we're just going to even look at it. We're not really going to do any problems. We're just going to look at mean deviation because mean deviation comes up a lot in the final exam as well. But that's a CST material thing. So the expectation, again, is that you know how to calculate mean deviation. And then the new things are actually very similar to mean deviation. So that skill will help us. So here, for the most part, you have some review that you could take a look at, just terminology, mean, median, mode, that kind of stuff. Mean deviation. So mean deviation, basically you have a data set, one variable, and it tells us on average how far each data point is away from the mean. So it's telling us how dispersed our data is. So a lower mean deviation means we're very close, all our points are very close to the average, to the mean. And a higher mean deviation means that we're really spread out and far away from the mean. So to calculate this, you use a table where you have the 4 different columns. So you have your X values in your data set. You have to calculate the mean. Then you take each number in your data set and you subtract the mean. So if your first number is 2 and your average is 5, 2 minus 5. So all of this column should be your data set, your points minus the mean. And then this column should be everything in this column, the numbers are the same, but you make them positive. And then the mean deviation is just you take this one and you divide by how many data points you have. So we'll do a quick one here. So I have this table. So the first thing I'm going to do, this happens again, you get this as a part A or B usually. So the first thing you're going to do is you're going to calculate the mean, which we represent by the symbol. So I add everything up. And I have 1, 2, 3, 4, 5, 6 different points. And if I do that, 60 plus 70 plus 80 plus 85 plus 90 plus 95, that gives me 480. Divided by 6 gives me 80. So now I'm going to fill out my table. This first column just tells me how many numbers I have. So I have 6 of them. It just helps me keep my data organized. The second column is my numbers. So I have 60, 70, 80, 85, 90, and 95. Now in the middle column, we take each of our numbers and we subtract the mean. So I have 60 minus 80 is negative 20. 70 minus 80 is negative 10. 80 minus 80 is 0. 85 minus 80 is 5. 90 minus 80 is 10. And 95 minus 80 is 15. And in this column, I take all of my numbers and I just make them positive. So the 20 becomes positive 20. The 10 becomes positive 10. 0 doesn't change. 5, 10, and 15 were already all positive to begin with. So my mean deviation is the sum of last column divided by n. So in this case, I have 20, 10, 0, 5, 10, 15. I have 6 data points. That gives me 60 over 6, which is 10. So the mean deviation is 10. So this you covered last or during the year in your during your CST class. So mean deviation was a big part of it. Everyone familiar with this, hopefully. So what we are going to be doing is a different type of calculation. So the mean deviation represents, on average, how far we are away from the mean. So we're going to be talking about variance and standard deviation. So variance is the average of the squares of the deviations from the mean. So what this column is, that column is the deviation. Or pretty much this column is the deviation. Deviation means the deviate is go away from. That's what the definition of that word means. So when I'm deviating from the mean, I'm away from the mean. So this little data point here is 20 away from the mean. It deviates from the mean by 20. So variance is average of the squares of the deviations from the mean. So all that changes is that this column, instead of just making it positive, you're going to take this column and square it. And then you do the same thing. You're going to sum it up and you're going to divide by n. That is going to give you the variance. Now the standard deviation is just that we take the square root of that. Okay. There are two different cases. Okay. So if you're told that the data set is a sample, which means if we remember back to our different stats units that we've done, a population is an entire group of what we're looking at. It's going to say variance or standard deviation. Like it has to say that. Like, you know how the problems before would say, like, you got it in a part A or part B, they'd give you a data set and it would be like, find the mean deviation. Now it's going to say find the variance or find the standard deviation. It's the same kind of problem. So there are two different things. If you have a sample of the population, when you're doing the calculation, instead of just dividing by n, you have to divide by n minus 1, where n is your sample size. And that s squared that we call this is the variance. So this is just a symbol. If it says the word, and it's going to say the word sample or population. If it doesn't, you default to this one. So it's going to say population. And what you do is you just divide by the entire population. So this is sigma. It's a Greek letter. Math likes to borrow Greek letters, so it uses a whole bunch of Greek letters and symbols to represent different values. And then the standard deviation is I just take whatever I did here and I square root it. So it's that simple. It's tables, again, it's the exact same tables. So let's take a look at how we do these problems. Calculate the variance and the standard deviation of the sample below. So first we need the mean. So we have 17 plus 18 plus 25 plus 19 plus 25. I have 1, 2, 3, 4, 5. 17 plus 18 plus 25 plus 19 plus 25 divided by 5 is 20.8. Ew, that's okay. So I have 1, 2, 3, 4, 5 different numbers. What are my numbers? 17, 18, 25, 19, 25. Now you can show your work here if you want to and do the subtraction there, but you don't have to. Just do the subtraction and you can fill it in, that's fine. 4.2. So now you're taking each of these numbers and you're squaring them, not making them positive, you're squaring them. So it takes a little bit longer than the other one because you can't just make it positive, you actually have to do some calculations. So this is 4.2 squared is 17.64, 1.8 squared is 3.24, and 4.2 we already did. Now what we're going to do is we need to identify if it's a sample or a population. The word sample is present, so we use this one. Sum, last column. divided by n minus 1. So I have 14.44 plus 7.84 plus 17.64 plus 3.24 plus 17.64 divided by, I have 5 minus 1. So 14.44 plus 7.84 plus 17.64 plus 3.24 plus 17.64 gives me 60.8. And divided by 4 gives me 15.2. So this is the variance. So notice the calculations are pretty much all the same, except that this column is the square of this column. So it's not more complicated than mean deviation. Then the standard deviation, we take the square root of the variance. So I take the square root of 15.2. So the standard deviation is 3.9. Type of questions that you could expect. Usually this would be a part A or part B, and it would give you a data set. And it would either say, calculate the variance or calculate the standard deviation of this data set. Cool? Okay, hold on. 3 questions all at once. Why do I square root? They asked for the variance and the standard deviation. When I do this calculation, that's the variance. According to our rules here, I take the square root of that to give me the standard deviation. So this is the variance, this is standard deviation. Why is the mean over 8? That's a 5. Just wrote it funky. Why do I subtract by 1? Because if it is a sample, then I have to use this rule, which is n divided by 1. If it says population, I do not minus 1. Cool? Let's do a couple more. Calculate the standard deviation and the variance from the following population. Okay, so we fill this out. 5, 18, that doesn't go in that column. There are 5 numbers. 5, 18, 10, 12, and 15. Just so you know, this column is kind of optional. You don't have to put it if you don't want to put it, but it just helps you make sure you don't miss any numbers. But if you get this for some reason, some sort of like part C question, you won't lose any marks if you don't put that column. So I need the mean, which is 5 plus 18 plus 10 plus 12 plus 15, and I divide by 5. So 5 plus 18 plus 10 plus 12 plus 15 divided by 5 gives me 12. So this column, 5 minus 12 is negative 7. 18 minus 12 is 6. 10 minus 12 is negative 2. 12 minus 12 is 0. 15 minus 12 is 3. So remembering to fill out our last column now, negative 7 squared is 49. 6 squared is 36. 2 squared is 4. 0 squared is 0. And 3 squared is 9. So for the variance, so now because it's a population, we go to the formula that's population. So we use this little sigma symbol. And it's the sum of the last column divided by n. So sigma is the sum of the last column divided by n. So here I get 49 plus 36 plus 4 plus 0 plus 9 divided by 5. So I get 98 divided by 5, which equals 19.6. To get the standard deviation, that is sigma squared is 19.6. I square root, and that gives me 4.43 as my standard deviation. So this again represents, it's talking about how spread out the data kind of is. So a bigger standard deviation means we have a lot of difference from the mean. Everything's really spread out. And a small standard deviation or small variance means that we're close to the mean. Like all of our values are very close to our average. Was that problem clear for everybody? Were there any questions before I move on to number 3? Two countries, north and south, in 2 counties, north and south, in California have problems with earthquakes, which are measured over the Richter scale from 1 to 10. Higher means more severe earthquakes. So in the north, the mean, the average is 5, so a scale 5 earthquake, with a standard deviation of 1.5. South, the mean is 5, but the standard deviation is 3. What county would you rather live in? So I'm going to take a minute. Either type in north or south. What do we think? No opinions, not even any guesses. 1, 2, 3, 4. 5. Okay, some people are awake and paying attention. It depends. I personally would rather live in the north. Why? Because they have the same average. So on average, they get the same level of earthquake. But here, this means the standard deviation. So in this case, the south, their data is spread out, extremely spread out. Because to get a mean of 5, I could have 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 10, 8, 9, okay? Or to get, county is the US. In California, there's no snow, but the north and the south of California, there's still no snow. It has to do with earthquakes, guys, come on. Or I could have 4, 4, 4, 5, 5, 6, 6, 6. So I would rather live in a place that doesn't get a 9. So this would more likely be something that the south looks like, and this would more likely be something that the north looks like. So a bigger standard deviation means there's a great deviation from the mean, and a lower standard deviation means we're closer to the mean. So in that case, the north would have less severe earthquakes. So personally, I'd rather live in the north. But in both cases, there's no snow anyways. Does that make sense? Okay, let's do of California. California is pretty hot. the whole state. Northern California, Southern California is still warmer than here. Still no snow. I personally am not a huge snow person. Some of you may love the snow with the snowboarding and the skiing and all that stuff, but I'm an extremely clumsy human being and skiing and me don't mix, so I prefer no snow. But it depends on you. All right. Oh, this one's a pain. They're both pains. Let's do them. All right, one more, and then we're going to move on to what we actually use this for. Just to give me some room here. All right, so the first thing that I want to do, I'm just going to move this down a little, is calculate the mean. So 60, 70, 65. You know what? I'm lazy. Plus, 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 plus. Divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I am Canadian. I just don't do the skiing thing. Tried it once. I fell down a lot. So I get 72. So then I fill my table out. So I have 10 points. 60, 70, 65, 80, 85, 70, 65, 80, 50, 95, 65, 80, 50, 95. All right, so then in this column, we subtract the mean. So I'm just going to plug in the numbers. You can do the work if you want, but you don't have to. Negative 12, negative 2, negative 7, 8, 13, negative 2, negative 7, 8, negative 22, and 23. So then I square this, 144, 4, 49, 64, 169, 4, 49, 64, 22, I don't know off by heart, 44, and I don't know 23 off by heart either, 529. So far so good? Okay. We're just going to change this to population because more than likely you're going to get a population. We just have to acknowledge the fact that there's a different formula, a different way to do this if this is a sample. So variance, we're going to take the last column and add it up. So I have 144, 449. 64, 169. 449, 64, 484. You should never, okay, so the question is if we square the mean deviation, it should not come out as a negative. You mean if you square this column, so remember, this is the deviation, not the mean deviation, okay? If you square this column and it comes out negative, it's because you're not using brackets on your calculator. This column should always be positive. So when you plug in negative 12 squared, if you type this into your calculator, what the calculator registers this as is -1 times 12 squared. According to BEDMAS, it'll do this first and give you -144. But if you type it in like this, which is actually the way you intend to type it in, this means negative 12 times negative 12, which gives you positive 144. So the calculator, if you type it in like this, defaults to this. So make sure that you use brackets. So then I have this divided by 10. So I get 156. Everyone good with that? All right, and then the variance, sorry, that was the variance, the standard deviation. We take this value and we square root it to give me 12.49. Did you? I got 1560. Anyone else get 2120? Or did I make a mistake? That's not a 6, that's a sigma. It's like a, looks like this kind of thing. That's the symbol. Questions? So this again could be a part A/B question. You just would have to do it like mean deviation. So we have one little thing left to talk about and then we're done with material. It's very exciting. Are there any questions with this? Cool. What do we use this for? We use this for a Z-score. So you may have heard this before. Basically, every data set, this is a bell curve, and this is what every data set should look like. So we have the mean, which is here. This is the mean. And each of these are standard deviations, okay? Meaning that as we go further away from the mean, we get less and less data set. We get less and less values, okay? So most people, 68% of people, will be within one standard deviation from the mean. So if we go back to this, a standard deviation is, in this case, 12.49. What this means is if I take 72 plus 12.49, that gives me 84.49. And 72 minus 12.49 gives me 59.51. 68% of my data should fall within this range. And then if I increase by another standard deviation, 95% of the data will fall within that range. And then if I increase by another standard deviation, 99.7% or 99.7% of the data will fall within 3 standard deviations. So it creates an interval of numbers that a certain percentage of the people or of the points in my data set will fall within. So what we call a Z-score, tells us where we are going to fall. So do we fall here? Do we fall here? Do we fall here? We don't know, but we'd like to know. So there are 3 different cases for standard deviation, for Z-scores. Either it's positive, which means you're bigger than the average, negative, which means you're less than the average, or 0, which means you're equal to the average. So it's a very straightforward calculation. It's actually the same for sample and population, but this symbol is different. Doesn't really matter. So what you are doing is you are taking your score minus the mean divided by the standard deviation. So that's why we calculated standard deviation. So there are 4 different types of problems that we could do. Okay? So let's get it started. Does everyone understand kind of what we're doing here? What this means? So your Z-score essentially tells you where you're going to fall within this normal distribution. So when they look at ministry exams, when they look at all of these kind of things, when they look across the province, this is how everyone in the province, if you group them all together, this is how it should look. They look at that stuff. It's pretty cool. So there are different types of problems that we could do. So we'll take a look at a couple of them quickly. They're very straightforward calculations. Marcus got a 75% on his last math test. If the class average was 70 and the standard deviation was 10, what was his Z-score? Do you know when we are going to get our MEES paper exams? That's on Tuesday. That's your MEES exam. It's your ministry exam. When you get the marks, August 3rd. So my Z-score is going to be my score minus my mean divided by my standard deviation. Remembering that this is a symbol, not a 6. So he scored a 75. The class average was a 70, and the standard deviation was a 10. This gives me 5 over 10, which is 0.5. What this means is he's somewhere in here. Because he's not 1 full standard deviation away, he's somewhere in the middle here, along with 68% of the data. So that's case scenario number 1 for a calculation. Is this clear for everybody? Kim's Z-score on her last test was negative 1.5. If the class average was 80 and the standard deviation was 8, what was her score? So it says Z-score. So I write down my formula. I fill in what I know. I know that the Z-score is negative 1.5. I don't know what her grade is, so I'm going to leave that as an X. The class average was 80, and the standard deviation was 8. I bring this up. So 8 times negative 1.5 gives me negative 12. And if I bring this over, her score was 68. So that's case scenario number 2. So the first one was when we wanted the Z-score. This one is when we wanted her score. Case scenario number 3 is when we need the class average. And case scenario number 4 is when we need the standard deviation. That's it. These are as complicated as these calculations get. Daniel got 80% on his last science test. Can you look at the first one? Did I just zoom too fast? In this case, it doesn't matter. When you're doing the actual standard deviation calculation, they're going to say sample or population in the problem. For this one, it doesn't make a difference. It's just a symbol thing, so it really doesn't matter. We good to go? Fabulous. Daniel got 80% in his last science test. If the class average was 75 and the standard deviation was, I don't want to do this one. It's the same case scenario. All right, Haley got 96%. We're on the next page. Haley got 96% on her last math test, and her Z-score was 3. If the standard deviation for her class was 6, what was the class average? Z-score, x minus x bar divided by this sigma thing. We know that her Z-score was 3. Her mark was 96. I don't know what the class average was, but I know that the standard deviation was 6. So I bring this up and it multiplies. 18 equals 96 minus the class average. I'm going to switch this. I'm going to move the class average over and it becomes positive. I'm going to move the 18 over. So 96 minus 18 gives me 78. So the class average was 78%. That's case scenario of a problem number 3. Good to go? This is case scenario number 4. Tasha got 86% on her last math test and her Z-score was 1.3. If the class average was 73, what was the standard deviation for her class? Z equals x minus x bar divided by the standard deviation. So her Z-score was 1.3. She got 86. Class average was 73, and we've got this like sigma thing here that we're looking for. So 1.3 is 86 minus 73 gives me 13. I'm just going to swap these because I can do that. It's like cross multiplying and dividing, but skipping a step. 13 divided by 1.3. So her class average was, or her standard deviation for the class was 10. So those are the 4 basic case scenarios that you can have. Obviously, the problems can get bigger and more complicated, like you're missing something for somebody and then you have to calculate it. Using that, you have to calculate it for somebody else, kind of like the forwards, backwards type problems. For instance, David and Eddie are in the same math class. The class average on the last test was 72. David earned a grade of 87 on the test, which corresponded to a Z-score of 1.5. Eddie's Z-score was 1.2. What was Eddie's result? So for David, we're going to start with David. I have Z equals x minus x bar over the sigma, and we'll do Eddie at the same time. Didn't expect the eraser to be. So we're going to fill in what I know. So I know that the class average was 72. I know David earned a grade of 87 and he got 1.5. I don't know the standard deviation. For Eddie, he got 1.2. I don't know his result though. So before I continue with Eddie, I'm going to look at David because David will allow me to get the standard deviation. So 1.5 equals 87 minus 72 is 15. I can do my swap. So what I get is 10. So that allowed me to calculate the standard deviation. Now, given the standard deviation, I can calculate Eddie's mark. So this multiplies up, so 12 equals x minus 72. And if the 72 moves over, I get 84 was his mark. So see how we can work backwards with one thing and work forwards with the other. How are we feeling with Z scores? And standard deviation variance? It's nice to end on a bit of a lighter note, eh? So this brings us to the end of new material. Congratulations. Tomorrow, what we are going to do is I am going to do problems and problems and problems and more problems. So if there are any specific problems that you want to see done, send me an email, or I'm going to create a post. Here, this is actually more efficient, okay? Questions for review. The Z-score tells us where they fall within this distribution, okay? Within this bell curve. So like the 1.2 would be here. So he's gonna fall within this thing here, okay? So I've just created a post. I'm not looking at anything else. What I want you to do is I want you to post here, add class comment, assignment 5, number 2, assignment 8, number 4. Handout 5, number 12. Anything like that, post it on here, and I will try to hit up as many of those problems as possible, and I want to cover as many exam type problems as possible. So take a look as well at these review finals and all of the assignments. Even if you don't have time to go over them, if there are some that we haven't done that you want to take a look at them and post them on this stream, okay? And then I'll take a look at them tomorrow. So tomorrow is we're reviewing. It's our last time together. This is the end of the new material, so we want to make sure we're all prepared for the exam. And you should be working on your memory aid. So you'll get an assignment 14, which is just some Z-score calculations and some standard deviation calculations. Any questions? The topics are already posted in the notes section on the course outline. They've been posted since day 1. Anything else? Yeah, those are all the topics that are fair game for the exam. That's everything in the course. I can't narrow it down. You just have to be prepared for everything. I have no idea what they're going to put on the exam, but those are all the fair game materials that you could be are expected to know all of those things, because any of those things could end up on the exam. It's just like the other final. You have to know everything, and then whatever they put on, they put on. All right, have a great afternoon, everybody, and see you tomorrow.